Welcome to another episode of Learning Series where we talk about the science behind rocket science. This week we're going to be talking about thermodynamics, and we have Anna Maria from Papaya Tutors who's going to break down the science in a very simple term. So go ahead and take it away.
Hi guys! So for this week's Learning Series, we're going to talk about thermodynamics, which is a subject I really enjoy. So I hope you like it. When we start learning about thermodynamics, the first thing we have to deal with are the laws of thermodynamics. Now we have the zeroth law that basically has to do with thermal equilibrium and how if two bodies are at thermal equilibrium, then they have the same temperature. Then we have the first law. The first law is everything to do with energy and how energy can be destroyed or created. And for the second law, we have entropy. It deals with entropy and how the entropy of the universe in any spontaneous process has to increase. So how do we apply all of these laws into our thermodynamic systems? So the first step would be to know how to identify the phase of a system. This way we can get all of the information and all of the different properties from our thermodynamics tables. Now, in order to do so, we need at least two intensive properties that are independent from each other. Now, with these two properties, we're going to be able to actually pinpoint kind of the phase in which our substance is and look it up in our thermodynamics tables, and then we'll have all of the other information to allow us to actually analyze our system. We can also use the pressure versus specific volume graph or diagram that I have below. So in this one, we are going to be able to kind of put our states throughout the diagram so we can actually identify how our process is working and how it's changing. Now, we're not always going to find the substance we're working with in our thermodynamics tables. So we have other formulas that will help us figure out the different properties that we need, such as the ideal gas equation. Now, you've probably seen this equation before, but there is the compressibility factor I want to talk about. Now, in the case of ideal gases, this compressibility factor is 1. But for gases that kind of behave ideally but not really, it varies. Now, this compressibility factor is basically the relationship between the temperature and pressure of the substance to its critical pressure and temperature. This way we can get to know how far or close we are to this ideal behavior. Now, we also have mixtures of gases. Now, to work with this, we basically use fractions that are going to give us the relationship between maybe the mass of the whole substance to its individual parts. Now, in the case of ideal gases, we have two laws that we can talk about, which are the Dalton laws and the Avogadro's laws. Now, for the Dalton one, it basically states that the sum of all the pressures of the different components of our mixture is the pressure of the mixture as a whole. We have a pretty good example down there in a picture. And for Avogadro, it is basically the same thing, but in the case of volume. So now that we know about how to identify the phase of a substance, we need to talk about processes. Now, these processes are basically going to change the state our substance is in to another one. We have some common processes such as the isobaric process, which basically states that from one state to the other, they're going to have the same pressure. Have the isochoric, that is the same thing but with volume, isothermal, and so on. Now, these ones are pretty useful because we can kind of drag information from one state to the other, and it's going to help us collect data for the procedures that are going to come. Now we go into the first law. For the first law, the first thing we need to know is to identify what kind of system we have. If it's a closed system, which means that there's no mass going through it, or if it's a controlled volume, which basically means that there is going to be a flow. Now that we have identified what type of system this is, we can do the energy balance. Now, this energy balance is basically states that the addition of all the energy going in has to be the same one as the energy going out. And we can do that throughout these two different equations. And this is the topic of thermodynamics that I really enjoyed because it was pretty easy to understand, because it's basically a balance of energies. Now we can go into our second law. For our second law, we talk about entropy. And this entropy is pretty useful. It can basically tell us the efficiency of our process and if it's going in the right direction. For this, we make a kind of entropy balance. This balance is basically going to give us the generated entropy. Now, depending on the value of the entropy, we'll get to know different things about our process. For example, if it's greater than 0, then it's an irreversible process. If it's equal to 0, then it's a reversible process. But if it's less than 0, then it basically means it's an impossible process. So always have in mind entropy because it's pretty useful, and it's one of our last steps of our thermodynamic analysis. So how do we apply all of this into rocket science? So thermodynamics is a kind of step-by-step process, so that's exactly what we're going to do. Here we have a rocket engine, and which is going to have a substance going through it. Now, we first would have to analyze the phases in which this substance is going to be throughout the engine. As we talked about before, we can get maybe the information from our thermodynamics tables, or in this case, we're going to identify the substance going through as an ideal gas. So we have all of our equations for it. Now that we have our phase identified, this will basically give us the different properties that we're going to need for our energy balance. In our energy balance, we're gonna basically figure out the heat exchange, the work that is being done, and also the difference in energy of our substance. Now, with all of this information, we can go into the entropy analysis. Now, for the entropy analysis, we can use all of the information we got from the previous steps and figure out the entropy generated of our process. So this way we can analyze it and see if it's reversible, if it's irreversible, or if it's actually possible. Thermodynamics was a class I really enjoyed taking, and one of the reasons I think is because I could understand all of the theory that was going on behind the math that we were doing. I think I read almost all of the book because it was pretty interesting in why all of these different phenomena happened. So if you're gonna take the class, don't just have the formulas and apply them. Really understanding how this system is working and why these different things are happening is gonna help you a lot. In my case, it even helped more than practicing a lot of exercises. So good luck, and I hope you liked this learning series.